Okay, so we're asked to show that this rather nasty looking fraction here can be written in a slightly nicer form where a and b are integers. Let's just remind ourselves what an integer is. An integer is a whole number. Okay, so like 1, 2, 3 or 4, etc., but not a half or something. Right, okay, so how do we do this? Well, let's write it down and have a good look at it, shall we? So 6 minus the square root of 8 all over the square root of 2 minus 1. Now we are clearly dealing with surds here, and the reason I know that is because of these two numbers here, root 2 and the root 8. Remember, a surd is the square root of a non-square number, okay, and 2 and 8 are not square numbers. And we have a process for doing this, and it'll be clear why we do this in a moment. But if we're trying to simplify this, which we are, what we do is we look at the bottom and we multiply the bottom by the same thing but with the other sign in the middle. So we've got root 2 minus 1, so we multiply by root 2 plus 1. But I'm not allowed to change the fraction, so if I multiply by that on the bottom, I must multiply by the same thing on the top. And that will, I hope, simplify this a lot. Well, let's have a look at why it does. Okay, well, let's have a look at the bottom first. The bottom is root 2 minus 1 times root 2 plus 1. Now you may recognize this type of factorization as the difference of two squares. Look, it's a minus b times a plus b. And in this case, a is root 2 and b is 1, so we could do that. Now we could use FOIL to multiply this out, but actually because I've got the difference of two squares written down here, I know that that's just going to be a squared minus b squared. Well, a is root 2, so a squared is 2. That's the point of a square root. If you multiply it by itself, you get the number under the square root. And then minus b squared. Well, b is 1, so that's 2 minus 1. Which is just 1, is it not? So in fact, I can write this as 6 minus root 8, and notice I'm using brackets now, times root 2 plus 1, that's the top, over 1. And that 1 came from the 2 minus 1 there. As I say, you could use FOIL to multiply out the bottom, but we don't need to. Now I am going to use FOIL to multiply out the top. Okay, if you remember what FOIL stands for, or if you don't know what FOIL stands for, it stands for first, outer, inner, last. Now there are other ways of multiplying out two brackets, which is what I'm going to do now, but actually FOIL means you multiply the first term in each bracket together, and then the outer pair, and then the inner pair, and then the last pair of terms, like that. So let's do that. So 6 times root 2 is 6 root 2. The outer pair was 6 times 1, so that's 6. The inner pair is minus root 8 times root 2. We'll think about that in a minute. And then minus root 8 times 1 is minus root 8. Okay, well, let's go through simplifying this if we can. So I've got 6 root 2 plus 6. Now, root 2 times root 8 is 8 times 2 is 16, so that's root 16. Let's just write that down over here. Root 2 times root 8 is root 16, and root 16 is 4, so that's minus 4 there. Now, before I tackle the root 8, let's just think what we're going for. We're going for something which has only got root 2's in it. So can we actually simplify the root 8? Okay, well, we can, I hope, because if you think about root 8, and this is a very standard way of simplifying a surd, you split it, oops, not an equal times, but an equals, into a square factor and a non-square factor like that. So 8 is 4, which is a square number, times 2. So root 8 is root 4 times root 2, and 4 is 2. So that is 2 root 2. So we're going to simplify root 8 like that, and then bring it back in here. So that's minus 2 root 2. And now I hope we can simplify this into the form we want it. 6 minus 4 is 2, and then I've got 6 root 2 minus 2 root 2, and 6 take away 2 is 4. So this is 2 plus 4 root 2, and that is in the form I wanted it, which is a, which is 2, plus b, which is 4, times root 2. And we are done.